Hey guys, here we're talking about complex numbers and roots. So we just got done before fall break with um, radicals, square roots, things like that, simplifying on perfect square radicals. Here we're going to talk more about that. We're going to introduce a new thing. We're going to introduce square roots of negative numbers now. So beforehand, we talked about square root of 4, right? How that equaled 2 or something, right? Or we talked about the square root of something that wasn't a perfect square like 20, and how we broke it into a perfect square like 4 times 5, right? To simplify that to become 2 square root of 5. If you need a review on that, please review on that because it's something we still need to be aware of. But now we're going to talk about, well, what happens if I have the square root of negative 4 or the square root of negative 20? How does that change things? Because it's not going to be quite the same. It's going to be similar, but it's not going to be quite the same. Because you can't really do square roots of negative numbers. The reason is because if you square root a negative number, you're asking what number would I square that would equal negative 4? And the answer is there is no such number because anything you square would always be positive. It will never be a negative number. 2 times 2 is positive 4, and negative 2 times negative 2 is positive 4. So negative 2 squared is still positive 4, and a positive 2 squared is still positive 4. Because a negative times a negative is always positive, and a positive times a positive is always positive. The only way to get a negative is a positive times a negative. But when you're squaring something, you're not multiplying it by the opposite version, you're multiplying it by itself. So it has to be the same sign both times. So how are we going to deal with that? It's pretty easy. And what we actually call these is imaginary numbers because it doesn't really exist. It only exists in our imagination, which is not true, but I'm just trying to make jokes, okay? Imaginary numbers. That's the idea here, okay? I had a funny GIF, but it didn't show up. That's okay. Oh, you saw a glimpse of it. Nope. It's an imagination from SpongeBob because it's imaginary numbers. Anyway, pure imaginary numbers are square roots of negative numbers. So imaginary numbers can be written in the form bi, where b is a real number and I is the imaginary number. So something like, 2i or 3i. These are imaginary numbers. But what is I? Where did that come from all of a sudden? So I is the whole premise behind imaginary numbers, and I is always equal to the square root of negative 1. Okay? So just remember that, right? I is always the square root of negative 1. From here on out, whenever I write I, I'm writing the square root of negative 1. So 2i is 2 times the square root of negative 1. Okay? 3i is 3 times the square root of negative 1. I is always the square root of negative 1. Now remember, there's no such thing as a square root of negative 1 because there's no such number that multiplies by itself to equal negative 1, which is why we call it I for imaginary, because it doesn't really exist. It just does in our imagination. But by changing something we can't physically do to a letter like I, makes math simple for us. It makes things a little bit easier to understand in the context of a lot of different things. So it does have a purpose. It's not just we're doing this because someone made it up one day and thought it would be fun. It does have a purpose behind it, but here we're talking about at least kind of getting used to it and being familiar with what it is. Okay, so I is the square root of negative 1. Now, even though it's a square root of negative 1, every time we see I, we're just going to keep calling it I. We're not going to just write it as square root of negative 1. Now, I squared is, well, the square root of negative 1 squared. Now, what is that, though? Because you're squaring something you have the square root of. So when you square something that has a square root, what happens is that the square root and the squared cancel each other out. So I squared is really just a normal negative 1, which is interesting. And it's also another very important thing to know. So you always want to remember that I I is always the square root of negative 1. And you always want to know that I squared is just plain negative 1. These are two things that you always want to remember, especially this one. Okay. Now, I to the third power. I to the third power. Think of that as, well, I to the second times I. Because that's I to the second times I to the first, which means you have three i's multiplied together. Now, I to the second, as we just mentioned, is negative 1. So it's really like negative 1 times I. So I to the third power is like saying negative I. Because negative 1 times I is negative I. Now, similarly, I to the fourth power, think of that as I to the second times I to the second. Right? Which again, you know I to the second is negative 1. So you're doing really negative 1 times negative 1, which means I to the fourth is a positive 1. Now, these are four very crucial things to remember. And that this is a pattern that's going to continue as well, since this one ends in 1. So let me write them off to the side here. I, negative 1, negative I, and positive 1. These repeat, because when I do I to the fifth power, think of that as I to the fourth times I. Now remember, I to the fourth we just mentioned was 1. So it's 1 times I. So it's the same thing. I to the fifth is the same thing as I. I to the sixth power, think of that as I to the fourth. Think of that as I to the fourth times I to the second. 4 i's times 2 i's is 6 i's. So I to the sixth, same as I to the fourth times I to the second. Now I to the fourth, remember, same thing as 1. I to the second is the same thing as negative 1. So I to the sixth is the same as 1 times negative 1, which is just negative 1. So that's the same as I to the sixth. I to the seventh is I to the fourth times I to the third. So again, it's 1 times I to the third, which is negative I. So it's always going to be the same as this. And I to the eighth will be the same as this. And it keeps repeating. It repeats this pattern every 4 times. So let me try to erase this because I don't want to erase all of it. I just want to get rid of this stuff. So I to the fifth is I. I to the sixth is negative 1. I to the seventh is negative I. I to the eighth is 1. Then it repeats again. I to the ninth is I. I to the 10th is negative 1. I to the 11th is negative I. I to the 12th is 1. And it continues going over and over and over again. So it's always going to be one of these four. I, negative 1, negative I, or positive 1. So I to the 14th power, here's a trick to kind of help you out, because sometimes you're going to have I to like something ridiculously large, like I to the 79th power or something. But here we have relatively small ones, I to the 14th, I to the 21st. But here's a simple way to quickly identify which part of the pattern it's going to fall under. Will it fall under the first part, which is just I, the second part, which is negative 1, the third part, which is negative I, or the fourth part, which is positive 1? Take your exponent and divide it by 4, because it repeats every 4 times. So if you divide it by 4, you'll find out which part of the pattern it'll lie. If your answer ends in 0.25, that means it's I. It's going to be that part of the pattern. It'll be the first part of the pattern and it hits. So, for instance, 5, if I had I to the 5th power, and I didn't know what I to the 5th power was, I can take the 5 and divide it by 4, and I would have the number 1.25. And because it ends in 0.25, I know that means that 5 is the first part of the pattern, which means I know that I to the 5th power would be the same thing as just I. So, and again, if it ends in 0.5, it's the second part of the pattern, so it's the same thing as negative 1. If it ends in 0.75, it's the third part of the pattern, negative I. And if it ends as a perfect number, it's the fourth part of the pattern, and then it's 1. So if you take, like, example here, 14 and divide it by 4, I believe you get 3.5. And since it ends in 0.5, that means that this is the same as just negative 1. Okay? So keep it simple. 21, if you take 21 and divide it by 4, you get 5.25, I think. Which means, because it ends in 0.25, that this is the same thing as just regular I. So just use that little trick to kind of help you out, to sort of match up which part of the pattern your I falls under. I to the 40th, same idea. So take 40 divided by 4, and you'll see that it ends as 10. And since it ends as a whole number, that means it's just 1 in that fourth part of the pattern, which is 1. And then 53 divided by 4 is, gee, I don't know, but let's see. I'll just type in my calculator real quick. 53 divided by 4, 13.25. Since it ends in 0.25, that means it's just I. All right, we're going to ignore this because it's too confusing to explain. I like my trick better than this trick, so. All right. Multiplying imaginary numbers. We'll multiply and then we'll end the video here. So multiplying imaginary numbers is pretty straightforward. It's kind of like multiplying anything else. If you had, before we get to number 5, if you had negative 2x times 7x, you would have negative 14x squared, right? Because negative 2 times 7 is negative 14, and x times x is x squared. So it's very similar with I, but you have to be very aware of I as well. So this is going to be negative 14 I squared. But you don't want to leave it like that, because there's something I told you to remember. I squared is always the same as negative 1. So what we have here is negative 14 times negative 1, which really means it's positive 14. So you're not done when you write this, because I squared is not simplified. I squared is still negative 1. You have to remember that, and you have to take that into account. So here, negative 2i times negative 5i, that'll be a positive 10i squared. But remember, I squared is negative 1, so really we have negative 10 as a result here. Now, 4 times 6 will be 24, and I times I to the second will be I to the third. So remember, I to the third, if you go back and look at your notes, I to the third is the same as negative I. So this is really 24 times negative I, which makes it negative 24i. Here, let's just keep it simple. Negative 10 times negative 15 is a positive 150. And no I have to worry about here. We just kind of simplify this. It's the same as 25 times 6, I believe, which is 5 squared is 6. And here, 5 times 12 is 72, right? Positive 72, so it's the same as just 36 times 2, which is 6 squared of 2. So these last two are more or less the same as what we did before fall break. All right, I'm going to end that there. We'll start with the simplifying in terms of I next time, okay? Good luck. Bye, guys.